Okay, so we are pretty much the halfway point for this class. Even though the semester isn't over until the end of the month, it just works out that the third and fourth quarters are actually shorter than the first two. But what you guys need to understand is where we are right now is a very, very important point. We're kind of like at a turning point for the year. The first half is setting the stage for what we're going to be starting with today. And that is getting to the point where we can actually start using statistics. Why do we even have this? And we use statistics to be able to make inferences. And what an inference is it's kind of like an educated guess. Okay, we're trying to get to this point where we take a sample and we're going to use that sample to say something about the whole entire population. That's where we're going with this. Okay, so basically chapters 18 and 19 are going to be the last times that we see everything that we do, or not even everything that we do, but a majority of what we do is going to be new. Okay? You're going to see a lot of what we're talking about today actually comes back to what we did in chapter 17. But 18 and 19 are the last times that you see really new stuff. Then it starts regurgitating itself over and over and over again. Same thing, slightly different formula. Same thing, slightly different interpretation. But that means that 18 and 19 are hugely important chapters. And we're going to get to the point here where you actually have to start memorizing statements. Because with chapter 18 and 19, we get to the point where we have free response questions. You can actually do something called maximizing your score. That means you might not have a single clue what you're doing to get the math. But there are things that you can write down to still get credit. You should still be able to get a 2 out of 4 for most free response questions, even if you have no clue what you're doing. Okay? But it also means that there's a very tiny difference between a 3 and a 4. And that's all about context and being able to critically read. And so we have here is our first try. So we have a class, they took a large exam. Now I'm not taking everybody. This is not a class of 5 students. Do you get what I'm talking about here? I am randomly pulling 5 out. And the 5 that I pulled just so happened to have the scores listed. So can you tell me what the average of those scores is? 79.4, right? The average of the sample is 79.4. That is now called the point estimate. So that's saying based on my sample, the point that I have to estimate what's true about everybody is 79.4. It's just one point that I'm using as my estimate. Does that term point estimator make sense? Because a lot of this is breaking down the vocabulary. So population. For this, what would the population of interest be? The class. Okay? So the group I'm trying to learn about is the class. Now, if I've got my population, the parameter is the numeric value or the thing that I'm trying to find about the population. So what is it that I'm trying to find out about the population? The what? The mean of the scores, the average of the scores. The point estimate. What do I think the average score was? So if the population is the entire class, my parameter is the average of the large exam scores. That's what I'm trying to do. So what is my sample? The 5 scores. Those 5 scores. And so the statistic would be the mean of those 5 scores, which was what? 79.4. So what I can do here is my population and my parameter are kind of generic. I don't really know how big my population is, and I don't know what the actual parameter is. But I can take my sample of 5, get the statistic from that, and try to work with that to learn about what might be true with the whole group. It says, we're going to change your point estimate into an interval. So instead of saying, I think the average of the class is 79.4, I mean, if the average of the class is 79.6, I'm wrong, right? So I'm not going to say, okay, I'm like, okay, I get it. I only have 5 people in this group. So what I'm going to do is I'm going to change it from a point and I'm going to make it an interval. So you guys ever heard of that plus or minus a margin of error? Have you ever heard that statement before, maybe in politics or in the weather, give or take? Like we think the high for today is going to be, I think today was 51, and they usually are give or take 3 degrees. That's your margin of error. So if we want to say, okay, I've calculated the average of my sample to be 79.4. Give me a number that we will give or take. 5. Okay? What else could you have used? There's no right answer here. 3. No. 8, 6, 4, 2, 1. You can use anything for the margin of error. The bigger the margin of error I use, will I be correct more or less often? More often. If I say my margin of error is plus or minus, or let's say, you know what? I believe that the average score for the class is going to be between 0 and 105. How often do you think I'm going to be right? All the time. How informative was that answer? Not helpful. Okay, it's like, you're not helpful, dude. It's like, geez, what do you think the temperature is going to be tomorrow? I don't know. Between negative 200 and 200 degrees Fahrenheit. Like, not helping. So what we have here is we have this balance. We have a kind of a battle waging between being helpful and being right. I want to be right, but I don't want to just give you random stuff that doesn't mean anything. And so we're going to be picking our margin of error as we go through in a way to try to balance that idea of accuracy versus correctness. Okay? So if we chose a margin of error of 5, it's just an easy number to use, my interval would go from what to what? 74.4 to 84.4. Okay, it means I think, based on what I've done, based on my sample of 5 scores, I think the class average is probably going to be between 74.4 and 84.4. It's probably going to be a C or a B. They do this all the time. Last major election, the polls had Hillary Clinton with 51% of the vote. So they had called it that Hillary won the election. But if you look, like, they're always going to have like all of these crazy diagrams and all of these statistics and all of this information, and they're going to have Hillary wins, is what they did. Then if you look down in the corner, it's usually the bottom right corner. I don't know why, it just usually is. In very tiny print, they'll say plus or minus 3% or 4%, depending upon what it is. So saying Hillary Clinton will win with 51% of the vote. And then at the bottom they say, but I might be off by 3%. So in all actuality, she might be anywhere between 58 and 54. I'm sorry, 48 and 54. That's weird. And so within that, they're saying, she won, definite. But within that interval, the opposite was also true. Do you understand what I'm talking about? So they were right, but they weren't. Okay? Their final claim was off because of their margin of error. It doesn't mean that they did it wrong. Every single sample you take, if I took 5 students from the list and I got this, and you took 5 students from the list and you got a completely different set, different average, that doesn't mean either of us were wrong. There is an error built into everything that we do because samples change from one to the next. It's only really wrong and bad if we have bias in it. Like if I'm going to post and send out an email to parents and I want to take a sample of 5 students, I'm only going to take the 5 highest students. And I'm going to send that average out to everybody. The average of the exam was between a 92 and a 100. Makes me look really good. And then you go home like, Mom. And parents are like, why did you get a 74? Well, that's a bad example. And that's where they're going to always point fingers at. They're going to say, hey, who did you ask? Who was in your actual poll? All right, so we did our interval, and if we said 5, like plus or minus 5, how confident would you say you are in that? You're saying what? Say it again. 75%. I like the way that you're answering that, because when we talk about confidence, we talk about what percentage of the time am I going to be right. That doesn't mean that 75% of the scores are going to be in that window. What that says is if I were to do it over and over and over again, I think I'd be right 75% of the time. Same thing with the polls. They'll say they usually use like a 98% confidence. That means if they were to do it 100 times, they think they're going to be right 98% of the time. 98 of those. They'll be wrong twice. Okay? This time might just be one of those. Now, if one group did the same thing and this was their interval, what would their point estimate have been? So how did you get 75? Okay, and that gave you what? So you basically did it the exact opposite of what I did. It's perfectly right. Yeah, it's the exact middle. The point estimate is the exact middle. You find the average, add them, divide by 2. That's the point estimate. The margin of error is what you did first. It's just, it doesn't matter which one you do. It's just the order that I asked. The margin of error is you subtract and divide by 2. Does that make sense? And that's because a margin of error is supposed to go up and down the same distance. So it means my estimate will be right in the middle, and half that distance is going to be my margin of error. Okay? All right. So also, just to make sure you guys know, you probably are aware, your midterms are graded. They are in the grade book, and they have been backfilled. Okay? So yes, some people made drastic improvements. Some not so much, but mostly it was a big improvement. All right? But now, what we have done for that first half of this year, you need to know, you need to remember in order to be successful from here on out. Those are the building blocks. We're going to keep going back to it over and over again. So you need to be good with that. All right. So chapter 18 is about confidence intervals. And I want you to look at this one word right here. What's that word? Proportions. Chapter 17, before we took our midterm, chapter 17 was about sampling distributions, right? And we had 2 different situations. We had proportions and we had means. For this unit, for the remainder of this unit, we are just talking about proportions. Okay? The next unit will be about means. All right? So here we are talking about proportions, and our goal here is to go from a sample from data to the whole world, to our population of interest. That's where we're going. And I really need to put this in because that's a lot of words. I needed to do my animation here, and I didn't. So we've already kind of started breaking down some of this stuff. We set a point estimator. So Merry Christmas, you have this all printed out for you. You can just like highlight, underline, point, arrows. Oh my God, important! A point estimator is a point or a specific value that estimates what would actually be true about the whole thing. Mind blown. Right? No? Not really? Good. So that's your, either that can be a mean, it can be a proportion, it can be any type of a statistic. Now what we want with our point estimators, if I were to give you an estimate, and I were to say, this is the average, I want that average to be on point. You heard that saying before, on point? On point means 100% correct. The number I give you, I want it to be the average of the class. That says that it has no bias. Because what does bias do? It doesn't change the confidence. If we think back, what was bias? Volunteer bias, response bias. It skews your data. What does it mean to skew? Pulls it. So it's like if my point estimator, if I want it to be accurate, bias is going to take wherever I'm aiming and pull it off target a bit. Do you understand what I mean by that? Bias means it's not exactly accurate. And then it says we want low variability. What is variability? That's how we can measure variability. What does it mean to be variable? Okay, you're getting all the way, but just a variable? What is a variable? It's a change. We use X for an unknown because it can change. Depending upon what we're talking about, it will be different. When you're in algebra and you solve for X, your answer is not always the same thing. There it is. That's what X looks like. Now, have you ever seen that meme where someone says solve for X, they circle the X on the page and say there it is? Yeah. Now, X is a variable, it changes. Variability, going back to what you were saying, Deo, variability is how far you are off from what's true. So we want low variability. We don't want to be far off from the truth. So we want to be as accurate as possible. But if I were to do it a whole bunch of times, like if I was at a shooting range and I was to do it, like you would never find me at a shooting range. I am blind and no hand-eye coordination whatsoever. I would want all of those shots to be clustered tightly around what the actual aim, the target point is, right? Bias would mean if that cluster of points is off from where I'm actually aiming at. Variability is what I would have, which would mean, hey, look, Swiss cheese. Some blind person was shooting at a target. That's me. So you want no bias. You want to be kind of close to the average, and you want low variability. You want a lot of accuracy. Okay? And a confidence interval. This is the way that we're going to be writing it. C, or we'll say CL, this is going to be a number, like a percent, and the ones that we use most often are going to be 95 or 98. Sometimes we'll use 90, sometimes we'll use 99, but we want a strong confidence, and it's a percentage. And that says if I were to do this, if I were to take 1,000 shots and kind of draw little bullseyes around each of those shots, I should actually hit what I'm trying to hit that percent of the time. Okay? And what we have here, this is the general form of what we're going to be doing over and over and over again. What that is, you start with where do you think the truth is? Based off of your sample, where are we? Then you're going to go up and down the same number. So I'm not going to go up 3 and down 4. I'm going to go up and down the same number, and that number is your margin of error. That creates your confidence interval. Okay. So what this means, okay, that the difference between my estimate and what's actually true should fall in that margin of error, should be less than that margin of error some percentage of the time. So if I'm 95% confident, then whatever my margin of error is, within that will be the true value 95% of the time. Okay? So the confidence level gives you your overall success rate, and your interval is very specific to what you're talking about. So C percent, that means if I were to do it over and over again, this is very important, if I were to do it over and over again, how often would you be right? So if I were to take a sample of all of your guys' midterm exams, sample of 5 each and every time, would I always get the exact average? No. But if I make an interval, my interval within that, the average should be there, and depending upon how confident I am, that percentage of the time. We're almost never going to be 100% confident. Because if I'm going to be 100% confident, that means I'm going to tell you that your average is between 0 and 105. Yay! I'm always right. That means nothing. Okay? But if I want 50% confidence and I say, okay, we're going to be between, 83 and 84. I'm not going to be right very often. Okay, so we want that balance. Now, we get to our posters. These posters are all statements that you're going to have to memorize. Okay? These will not be on the board during tests and quizzes. That's why they're magnetized and not glued. I can take them down and put them back up, and take them down and put them back up. But you will have to memorize this. So for those of you who cannot see my posters, the first thing that you need to understand, and I've got them backwards here, doesn't really matter, is what a confidence level is. Okay? Because I will ask you to interpret a confidence interval. I will say interpret a confidence level. There's only one word difference between those. And you need to understand because those are two very different statements. A confidence level is generic. That means it doesn't matter what you actually got. It's about what are you doing. And the big thing with this is it has to be in context. And the things that you have to say for this. And you can see these are saying the same thing. The order is just different. You can see over here I've got it color-coded. You can mix and match the order of that stuff any which way that you want, but you have to have all of those pieces. Those pieces are, we are blank % confident. State your level. That repeated samples of size n, or you could have said, if many samples of the same size, sometimes they say if 100 samples were done, then the resulting confidence interval in these two numbers match should contain the population parameter in context. Over here I've got if repeated samples of size n were taken, about 98% of the resulting 98% confidence intervals would contain the true population parameter. Underline that, highlight that, write that 100 times when you get home. It's about maximizing your score. You have to have pieces that talk about if I were to do this a whole bunch of times, then whatever my level is, that percent of those confidence intervals, that specific % confidence interval, should capture what's actually true. You don't need to know a darn thing about calculations to answer that question. You can get that question 100% correct if you can look at the problem and pull out whatever the percentage was and whatever the context was. Maximize your score. So if I ask you, interpret the confidence level, 100% of you should get it right. There's no thinking involved. It's literally regurgitate. Spit it back out at me. Confidence interval. An interval is a specific value of numbers. So this guy is very specific to what you are actually doing. And of course, you've got to have this in context. Now, every time I say the word context, you guys should know that what's the most missed thing from any student on any problem? Context. Don't miss it. We're not going to be creative here. We are literally going to pull it straight from the problem. When in doubt, copy what the problem says, word for word. Wow, you get it right. Okay? So what do you have to have? You have to have, we are blank % confident. You have to have based on our sample. I don't care where you put those. See, they're switched over here. Based on our sample, we are 95% confident. We are 95% confident based on our sample. I don't care what the order is. That the true, whatever it is you're trying to measure, the population parameter, the context, will lie within the interval from to, where that to is basically the numbers you got from your math. So you might not have a single clue as to what to do for the entire problem, but you can make stuff up. And you can say, this, we are % confident based on our sample that the true context of the problem will lie within the interval, and just make numbers up. For a 4-part problem, you just got 3 of the 4 parts. Yay! Maximizing your scores. Last year I didn't have a single 1 on any of the AP tests. You should be able to get at least a 2 with just that. Do you understand what I'm telling you? 1 is not an option. Because if you maximize your score, nobody should get a 1. Okay? Memorize this, guys. And I'm not kidding. I kind of feel bad that I've given this to you, printed out on a piece of paper, but I didn't expect you to watch a video over winter break. So I didn't think you'd write it down ahead of time. Okay? You need to memorize this. Okay, so what does 95% confidence really mean? It means that I am 95% certain I have an eyelash in my eyeball. I hate that. Blech. Okay. So basically what it does is it starts with the idea of what did you get from your sample. Okay? For my first problem, my average was 79.4. It's going to all be based off of that. And the thing that you need to understand is because that 79.4 came from 5 numbers that I randomly picked, those randomly picked values are going to change. So for each time that you do that, your actual statistic is going to change. And if your statistic is going to change, then the window around it is also going to kind of shuffle left to right or wherever. And that's why confidence intervals will all be a little bit different. And that's not bad. It's not bad unless you've done it 100 times, and for all of those 100 times, every single one of those is pulled off. It's bias. It's not capturing because you've done something wrong in the situation. So here we have 20 different intervals. Each of these intervals, if you look, so that's about like 2 fingers here. That's the same. That's the same. All of these guys are the same width. My margin of error is calculated pretty much the same way. They're the same width. But they're all based off of whatever my statistic was. What did I get from my sample? And you can see each of these red dots, each of those are the sample. This green line, this is what's actually true. Are any of those samples centered perfectly, exactly on that green line? No, because unless you get everybody, you don't expect 100% perfection. It's very hard, especially when you're looking, take it out to 4 or 5 decimal places, it must be correct. Dude, no. But if we look at these, some of my intervals catch that green line or do a better job catching it than others. Does this get the truth? But this one. But that one. So some of these you can see get the truth because that interval, within that interval falls the green line. Not all of them. The interval does not catch it here. It doesn't catch it here. It doesn't catch it here. So if these are 20 intervals and 3 of them don't work, how many do work? 17. What is 17 out of 20? It is not 95%. 85%. That means that if I were to do this based off of this, I would say I'd have an 85% confidence. Because I should be right 85% of the time. I can do a lot more and see if that number changes, or I can do things that change my interval widths to make it so that maybe this one will pick up the average. And then I'll be at 90. Maybe I can make either one of these guys pick up the average, and then I'll be at 95%. But what our faith in is not in our answer, because this person will have just as much faith in their answer as this one will. It's about what process did you use to get your answer? How did you do the randomization? And that's why when we go through and we do statistics, we always we don't point at the math. We don't really question the numbers. We question the method. So our confidence, when we talk about a 95% confidence or an 80 or 100 or whatever it is we're talking about, it's not about your answer. Each of these people did the exact same thing. Each of those 20 individuals. So they should have the same level of confidence. But because samples vary from one to the other, it's the process itself that might give out different answers. Okay? This one's where I should have been 85. Okay. Hey, wait a minute. Have we seen this term before? Can you give me an assumption or condition that you have heard before? I don't care. Just give me something. 10%. Give me another one. Randomization. Independence. Greater than 30 if we're talking about means. If we're talking about proportions, we needed 10, at least 10 successes and 10 failures. Because what we're doing is we're saying, all right, if I have assumptions and conditions met, I can start working through these processes. So all of our statistical models, everything that we do in here is based on assumptions. Now, our confidence is in these assumptions, is in how I did this. So each model, because we do it slightly, we do different steps for proportions, for means, for counts, for all sorts of different things, means each process is going to change just a little bit. And if you trip up on any of your assumptions, that means the whole entire model is false. If I wanted to predict the next election and I went to a Republican conference and took a sample of 100 people, would you have confidence that that answer would be correct? No, it's biased. What kind of bias? One more time. It's going to be a bit response bias. Who you are asking is actually going to change your answers, where you are, how you're doing it. What if I were to do it on a website? You can have voluntary response bias because only certain people will be on those websites. What if you just asked your friends? Well, most of them result in undercoverage, but this is convenience bias because you're doing what's easy for you, but all of your friends have an underlying linking factor. You guys have a lot of similar beliefs. Do you see how all that old stuff plays up here? So we've got to be careful. If my assumptions are not met, then my total answer, no matter how careful I am, is going to be wrong. And assumptions, we talk a lot in a lot of the other classes like geometry. Don't ever assume the picture is drawn to scale. Don't ever assume this and this is true. Well, we kind of have to do that in statistics. That's why so many people are like, my mom is like, statistics. It's just lies. Horrible lies. It's because people say assumptions. You make an ass out of you and me. It's like the whole assume. Have you ever seen that before? If I said it, assume. And that's why a lot of people don't believe in statistics. Because they're founded on assumptions. And if your assumptions aren't met, then everything else is wrapped out. So what we do is, if we can't meet an assumption, we look at conditions that meet those. So, surprise, surprise. Have you ever seen this assumption before? Maybe once or twice. The independence assumption. You have to start with these things actually being independent. One may not affect the other. Otherwise, you're going to have bias. It's going to steer your answer off of what's actually true. And so if I can't tell by just looking at the problem that it's going to be independent. Coin flips, those should be independent. Rolling of a dice, those should be independent. Okay? Certain things should be independent. Your random number generator on your calculator, that should be independent. But if I can't say that I know that based on what the whole thing of it is, I have to meet my conditions. What are my conditions? Oh my gosh, all of this brand new info. No. Random. And guys, to meet the randomization condition, you have to see the word random. I know, mind blown. If they don't have the word random, it's not random. It's amazing how that works. Sometimes you can make the assumption that they're going to be representative. That's a lot harder, and that's where a lot of statistics fall. It's like if your sample isn't perfectly representative of the entire population, that's why things fail. Okay? So you want to make sure that we have random. Then we have that not too big, the 10% condition. So when we're talking about proportions, or anything, that basically means that you take your sample size, you times it by 10. Your whole population should be bigger than that. Because if you've gone over that, then your probabilities start to change as you go through, and that's no longer independent. Then, we had one more assumption. The sample size assumption. Give me one thing that we used to say sample size was big enough. Success, failure, what did that have to be? Greater than 10. What else? You had said something earlier. You gave me a number. 30. To have at least 30 if you're talking about actual means or measurements. Those are the things that you need in order to talk about the central limit theorem. Anybody remember what the central limit theorem is? The larger what gets? The larger the sample, the closer you start to approximate normal. That term normal, does that describe shape, center, or spread? No. Shape. You can always find a center. You can always find average. You can always find standard deviation. But you can only use your normal CDF, your inverse normal, your table of z-scores, your 68, 95, 99.7 rule if the shape is normal. Do you understand what I'm talking about? That's huge. A lot of you guys still are missing that idea. Normal is not a center in a spread. That's why we put center and spread there anyway. Normal is the shape. Normal says that we can then do different types of math about that. So, kind of squeezing all of this together, the general formula for confidence interval. And this guy right here, pretty much all the way down to the font, is the formula they give you on your formula sheet for the exam. You get a formula sheet? Yeah, it's actually like 8 pages. It's because like 4 of them are tables. And the other 4 is, let's see, actually no, they might be down to 3 for the others. Let's see how much space we can write to do this little bit of information. So they're really quite creative with that. They love to do it. Yes, they just kill them. All right, so every single confidence interval, every single one, proportions, means, when we're looking at 1, if we're looking at 2, if we're looking at all sorts of different things, it is built this way. It is centered on your statistic, whatever that might be. Whatever you observe. Plus or minus, this is your margin of error. It has a critical value. This critical value is tied to your confidence level directly. So if I'm using a 95% confidence level, that number is always going to be the same. If I'm using a 98% confidence level, that number is always going to be the same. And you'll actually get to the point where you memorize that number. Woohoo! And then your standard deviation. That's specific to the problem. Okay? So generally what we're talking about here is if I'm dealing a confidence intervals are based on our statistics. I do them because I don't know what the parameter is. If I don't know the parameter, if I don't know the mean or the proportion, I can't use standard deviation because each of those formulas require what's actually true. So what we do is we use something called standard error instead. It looks like almost exactly the same, just the notation is a little bit different. And then for your critical value, do you guys remember when I had the problem where we had a normal curve and we said the mean was that the 50% was below and above it in normal distribution? And we said, okay, let's say I wanted to find the middle 60%. If I wanted to figure out where the middle 60% was, how far up from 50 would I have to go? 30, because half of it would be above, half of it would be below. So above would take me to, if I balance 60% on 50, my upper end would be at what? 0.8. My lower level would be at 0.2. So what this formula is simply doing is it's calculating that value for me. Saying to find that value, I'm going to do inverse norm because I'm looking for the z-score. I'm going to do 0.5 plus whatever that percent is divided by 2. So this was 60 divided by 2 is 30. So I took half plus that, 0 and 1 because it's a z-score. And just remember that this value, and you are going to get an error message in your calculator if you don't remember this. This value, that x, always has to be a proportion. So if you use 98 instead of 0.98, your calculator will scream and cry at you. I wish it made sound effects. Ah! What are you doing? That'd be fun to hear during tests and quizzes. Ah! That's not stressful at all. Okay. Aren't you happy you have all of these literally written out for you today? Kind of a good day for this. All right. So when you are doing this, what we're focusing on today is the steps that I need to take before I can do any math. For basically from here on out, the first day we're going to talk about what the heck is any of this meaning. The second day we're always going to be then doing the math. You can't do the math unless you know what the heck you're talking about. So when we're trying to do confidence intervals, the first thing that you're going to do, well, you need to define what P is, but once you have that, you're going to check your conditions. You don't need to say random, question mark, 10%, question mark, large enough, question mark. You don't need to do that. But you do need to state, is it random? Did the word random pop up anywhere? If it doesn't, can you make the assumption that your sample is representative? Sometimes you can. Sometimes we literally use the words, we hope it's representative. Otherwise, we can't go on. Then you have to say the 10%. You have to show by checking. You have to say, okay, 124 is less than 10% of all of the students at Battlefield High School. Okay, or you could say there are more than 1,240 students at Battlefield High School. So either way you want to show that, that's fine. And then you have to do large enough. And for this unit, from where we're talking now about probabilities, the big enough is that you have to show the values for NP and NQ, your successes and failures, and state that they're big enough, that they're bigger than 10. And then if you have that, we can say the sampling distribution is approximately normal, and we can, hey, look, we've seen this before, right? The sampling distribution of X follows the normal model, centered at P, standard deviation of root PQ over N. The only problem here, P is a parameter or a statistic. What is P? Parameter or a statistic. We have P hat. P is the parameter. P hat is the statistic. So we're not going to know what P and Q are. So we're going to be using P hat and Q hat. That's why we don't call it standard deviation. We call it standard error. Okay? All right. These problems are no math problems. These problems are brain problems. Your calculator will not answer a darn thing about any of this. Your brain will. So this isn't in your notes, and I don't want you writing it down. I want you to think, share with each other, discuss it. How complicated or simple are these answers? Some of them are actually really ridiculously simple. Go for it. For problem 1, it's kind of scary that they use the term carefully explain. Just automatically makes you think, I'm going to write an entire paragraph here. Not really what you need here. This really can be done in a sentence. But I want you to tell me, what do you think? Tell me pieces that would go into interpreting a margin of error. What does that mean? Well, it even has the words plus or minus in it, so yeah. But what does it mean when they say the margin of error is plus or minus 4%? Okay, so there's going to be some point estimate. Okay, almost. You are missing one tiny little thing for that. Nope. And the reason why you missed it is because it doesn't come out and specify it in this problem. But they have some level of confidence in what they've done to be able to say that they believe that within that level of confidence, the truth is going to be within 4% of whatever they came up with. So if I were to kind of like say that as a full sentence, he believes that the true proportion of whatever the poll is measuring is within 4% of whatever they got with some level of confidence. Does that make sense? Okay, the election votes from 2016. Okay, so like a full example, I would say he has 95% confidence in the fact that the true percentage of voters who would vote for Trump in the upcoming election is within 4% of 48%. Or you could say that I believe that the true percentage of voters is going to be between 44 and 52%. Yeah, they don't give it to you, so you're going to be vague. It's okay. All right. Now, for 3, we're looking at several different things: population, sample, p hat, and then we're going to talk about the confidence interval. Can I do it? So for A, what is my population? Who am I trying to learn about? What am I trying to learn about? Cars. That's it, right? Cars. Probably specific to some general area. Like I really don't care what's going on with the cars in, I don't know, Bangladesh. I really don't need to know what's true about the cars in Toronto. Wherever this is, they want to know about the cars in that area. Right? Slightly different cars between Bangladesh and Toronto and Gainesville. Would you agree with that statement? If you've ever been out of the country, you'd notice they even have completely different models than we have. Okay? Even if you went to Toronto, Canada's got slightly different cars. All right. What is the sample? The 134 cars that we actually stopped. Think about that full context. All I'm interested in, all I know is the cars, possibly in some area. My sample is the 134 cars that were stopped. So P. What is P? What does P stand for in general? Proportion. Right? P is a proportion. So what proportion am I interested in getting? Take a look at this. What am I trying to estimate? I'm trying to estimate P. P is the percentage of all cars that may be unsafe. Look at the creativity involved in that. What is P hat? Bingo. P hat I actually have numbers for. It is 14 out of 134. Good? Okay, so now let's talk about whether or not we could create a confidence interval. In order to create a confidence interval, what do I need? I need statistics? Yes, probably. What do I need? Okay, I'm talking about my assumptions and conditions. What is my first assumption? Independence. Now, I don't know. Personally, I think that the cars should be independent unless I'm going around playing bumper cars with my actual cars. My car shouldn't affect the safety ratings on yours. So I think that's true, but I'm not quite sure. So what are my conditions that go into that? Had one person say it already. 10% in random. Does it use the word random in here? No. It doesn't show up at all. So if we don't have random, what do you have to say? Not assume it's random. We can't do that. We can hope that it is. We hope that it's representative. Because that's why I don't know what the area that we're looking for. If I set up a checkpoint in front of the entrance to Battlefield's parking lot, it should be representative if all I'm interested in learning about was Battlefield High School drivers. If I set up a checkpoint outside of Battlefield High School and I was interested in learning about Prince William County cars, that's not going to be representative. Do you see what I'm talking about there? So we're hoping, we don't know enough to be able to answer that question one way or the other. And if someone has a question about what we've done, that's where they're going to come back and look at. But I can't answer that because I don't have the information. So I say hope representative. All right, 10%. What do you think? 134 is 10% of what? $134 is 10% of what number? 1,340. I have a pretty good feeling that there are more than 1,340 cars that I'm interested in. Pretty good idea. Do I have any other conditions I need to check? Sample size? So for portions, what is that? I don't know. I'm hearing a lot of... It's 10. What is 10? The success failures. How many successes? 14. How many failures? 120. If you have 14 successes, you have 120 failures. Are those numbers bigger than 10? Yes. I kicked. So as long as my sample is representative, I should be good to go. Do you understand what I'm talking about here? We could put a little caveat in there. We say, I don't know. I don't know if it's representative or not, but if it is, I'm good. Read B. Go through B the same way we just did A. If you need to stand up, you're falling asleep, go back of the room and stand up. So for part B, what is the population? The general public. The general public is who I'm trying to learn about. Now the sample is what? Only the 602 people who voted. Okay? So we have sample, we have proportion. What is, we have population. What is P? It's not the level of support. P is a proportion. So it's the proportion of voters, like whoever you vote, or the proportion of people who favor or support what? Prayer in school. You want to make sure that you can pull this straight from the problem. Just understand what I'm measuring is not how do we measure a level. The level is a proportion. That's how we measure a level. It's like, where am I proportionately speaking? Because if I were to say the number of people that support, that number means nothing unless I'm talking about out of what, and that means it's a proportion. So P is the proportion of people who support prayer in schools among the general public. What would P hat be? The 488 out of 602. Specific to my sample. So in an overall sense, are my conditions met? Do a confidence interval here. I see a no. Yes, no, what do you think? Would a confidence interval be a good thing to do here? Do you think I would meet my assumptions and conditions? I have some funky looks. Why? No, why? Because what? We don't know how many people watch this show. You don't know what type of people watch this show. Bias. Exactly. A Catholic talk show is going to be a little bit different than Anarchists Anonymous. Okay? So what I need you guys, what you need to start thinking about here is why we did that whole thing on the way samples were taken. This sample, the way it's done, it's about a TV show asking viewers. That's response bias. They have to vote. What is that? In order to vote for a TV show, what other bias comes in with that? Voluntary response. So we have response bias because the people who actually are participating, we have voluntary response because even with that, they have to feel strong enough to participate. Okay, you see how all of these things come together. All right, so the way that this would have been written, you do not need to bullet out independence, randomization, 10% success, failure. You don't need to do that, but you do need to show that you are checking each of those. If you have something like for B, where it didn't work, you could skip straight to the fact that this is why it didn't work. I don't need to show all the ways that it does. Okay? Do you understand what I'm talking about there? If you know that it's not going to work, just tell me the way that it doesn't work. Otherwise, check them all. Okay. So this problem is in your notes. Go ahead, read through this problem. And what I want you to do is I want you to write down, what do you think I expect to see for these? Because this is the first setup that we're going to do for the math behind this. Math, yes. We're not at the numbers crunching spot, not really. What I'm going to be showing you guys here is not like a thoroughly worked out. This is minimum. Minimum expectations for this. These are my minimum expectations. So if you look here, problem number 1 asks you to identify the parameter of interest. The parameter of interest here is a P, because we're talking about proportions. Sometimes the parameter of interest will be an average, but here it's a P, proportion of. And then you're going to go to the problem, and you're basically going to pull what you're talking about. We're looking for the proportion that report that they often or always get enough sleep during the last 7 nights. You are pulling all of that straight from the problem. I don't need to be creative here. I just need to make sure that I'm thorough. Yes? No, that is not the parameter. 48% is that's the statistic. Okay? So the first thing that you need to do, this is absolute must. Every single problem, whether they bullet them out or not, because usually they'll just say create a confidence interval. You must start by identifying your parameter. Then you need to write down what your sample size is, because your sample size is going to answer your conditions and assumptions. I generally also, because you're going to have to do it anyway, I come through here, and this is where I state that P hat is 0.48, Q hat is 0.52, because you're going to need to have that done somewhere, one way or the other. If you do it exactly at this stage, I don't care, but know that you'll need that. You have to have your sample size here. These are good because if you put this here, instead of when you check your success failure, you can actually call that success and call that number failure and actually not show the numbers. You can write NP and NQ there instead. Do not round those values. Do not round. So if you look here, I'm told it was a random sample, and I literally say, I'm not guessing it's a random sample. I was told it was a random sample. 1,029 is less than 10%. My population is U.S. adults. And you could have said here the proportion of U.S. adults. That would have been fine also. Indicate that those two numbers show what they are, and state that they're bigger than 10, so it makes them large enough. And since number 2 asked you to check if the conditions are met, I have to say, conditions are met. And we're going to get more into this Next class, and the reason why I'm stating it here, and even for the next couple of chapters, it's not going to make sense, but you will have a 1 proportion z interval, a 2 proportion z interval, a 1 prop z test, a 1 sample z test, a 2 sample z test, a 1 sample z int, a 1 sample z test. You're going to have chi-square tests. You're going to have all sorts of things. Right now, we're starting with this. 1 proportion, because I only have 1 p. Are we okay on those? Any questions on what you have to show there? If you do these, this pretty much gets you a 2. For if you're talking about a test, if we were to just have 1 question, a 2 is basically going to be a 75. You have to, yes, you have to show it multiplied out. I'm less interested in this, and I'm more interested in this. Henry? I'm less interested in this than I am in this. This is the most important. Actually seeing those numbers. Not with proportions. Our next unit is going to be about means. We'll be using that then. Okay? All right. Now, before we can actually start calculating stuff, go back to what we had said about my confidence interval formula. We said to find a formula for confidence interval. It's your statistic, whatever you observe, plus or minus your critical value. And that critical value is your z. It's what you get from doing the inverse normal times your standard deviation. The only thing I'm going to tweak here is we said standard deviation is based off of the parameter. I don't have a parameter. So instead of talking about standard deviation, which is based off of a parameter, we're going to be using standard error, which is based off of the statistic. That's it. That's all I'm changing here. There's a lot of writing up here just to say that if I don't have p, I use p hat, and now I just call it a standard error. Does that make sense? So for confidence interval, this is what we're going to be using over and over and over and over again. Our statistic is p hat, plus or minus our critical value. For this unit, we're using z's. So that will be your z star, and you find z star using inverse norm. And then this is the formula, root p hat q hat over n. Okay? All right. See if you can do these. We're just going to get through these 2 and we'll stop. Actually, no, we'll get through number 5 because that still goes with this setup. For number 3, I'm going to show you again the exact interpretation that you need to write. I've got it color coordinated because I look for each of those sections. I don't really care what order they're in. You just have to make sure that you hit each of them. Based on our sample, because we're talking about an interval, it's very specific. We are 95% confident that the true proportion, okay, it's talking about your confidence and what we're talking about is a proportion. Context, U.S. adults who would correctly answer, wow, I don't know how to spell answer. Answer nitrogen. Is between 0.175 and 0.225. Or you could have said between 17.5% and 22.5%. But you've got to have those pieces. Based on our sample, a statement about confidence and what you're measuring, context, and then the actual interval itself. You could get a P on this for just stating that part, which has absolutely nothing to do with a calculation. And then the point estimate is just going to be what's in the middle. Add and divide by 2. The margin of error, half the distance. So subtract and divide by 2. You don't need to show that. I just show that to make sure you guys, if you didn't know where the calculation came from, you could have also said from 0.2 to 0.225. Oh, that's that much. Okay. Now the last one was just kind of funny. It said, if you were to guess at random, if I made a monkey do this, would you understand why there's a 25% should get the answer right? Why should it be 25%? Because how many answers are there? How many of them are correct? Dude, you just did probability. 1 out of 4 should be correct. So there's a 25% chance that a monkey gets it right. What do you think? Who's smarter, monkeys or U.S. adults? Obviously monkeys. Why are the monkeys smarter? And I'll show you what you would have to state for this. The statement for this is, since 25% or 0.25, I don't care which one you use, is higher than the entire interval, I have convincing evidence that less than 25% of U.S. adults would answer this question correctly. Okay? Again, the value that you're looking at is outside the interval, and not only outside it, but it's above the interval. So that gives me evidence that less than 25% would answer this question correctly. So what we focused on today was the interpretation stuff. Next class, we're going to get more into the calculations. We didn't get through all of this PowerPoint today. That's okay. We're going to finish it up next class. Whatever we don't finish next class, we'll do during Flex. So we will get through everything. And just so that you guys know, your homework, don't worry, there is no video. I'm not going to give you the video. It's not worth it. But you do have homework through my math lab. You can probably do the first half of the questions. 2 classes, the day of the quiz. Yes.